In this video, we are going to solve the following questions on trigonometry. The first question is on the concept of elevation and depression. Let's check the question. Let's say a pole is held vertically on the ground. Now the pole is 4 meters long. A point P is 6 meters away from the base of the pole, which means from the base of the pole, that's point M, to the point P there. Maybe let's put P just like that. Now, first question, calculate the angle of elevation of N from P, which simply means that you are putting your eye here. You are putting your eye at this point here, and then you are looking up. You are looking up, and then what is the angle of elevation? So they're actually talking about this angle here, which is taking you to point M. Now let's calculate that angle. What do we have? There is an angle that's being required from us. Let's call that angle X. And then from that right angle triangle, what are we given? We are given an opposite side, which is 4. And we are also given an adjacent side, which is 6. Now with this combination, you can recall that from this term, so you have O and A, which means you are supposed to use your tangent. Then your tan X is equals to opposite, it's 4 over 6. Then your X is going to be equals to your arc tan. On 6. Then let's put that on a calculator. Tan 4 over 6. It's giving us a 33.69. So this is giving us a 33.69. Now, 3 significant figures if it's a non-exact number, and if it's an angle, you are required to leave it in 1 decimal place, and then your 1 decimal place in this case is going to be this number here. Now let's see from this to this guy. Since this is more than 5, you are going to add 1, then you are going to get your 33.7 degrees. Next question, the distance Pn. First of all, let's check what do we have here. Distance Pn, it's actually this distance up here. That distance I've highlighted in blue. So since it's a right angle triangle and you already have the two sides, you can use the Pythagoras theorem. Or since you've already calculated the angle at P, you can use your SOHCAHTOA. Now, let's just use the Pythagoras theorem. From Pythagoras theorem, we know that the hypotenuse squared is equals to the sum of the other two sides. And hypotenuse is the side which is actually opposite to the 90 degrees. Opposite to the 90 degrees. It's this side here, which means your PN is actually the hypotenuse. So it's going to be a PN squared. Pn squared is equals to the sum of the other two, 4 and 6. 4 plus 6 then this is equals to 4, it's 16, 6, it's 36. And then 16 plus 36, that's 4 plus 2, that's 52. Then your Pn is equals to the square root of 52. Let's put that on a calculator. See the answer. It's giving us 7.2. 1, 1. So this is equals to then rounding off these to 3 significant figures. Since it's an exact number, you are going to underline this number here. Then since this one is actually less than 5, you are adding 0, so 1 plus 0 is giving us the same number, which is 1, so it's going to be 7.21 meters. Next question is now say the pole is moved a distance x meters from its original position. The new n is n prime and the new m it's m prime. So what actually happened here, we moved this point here to this new position there, and then we have a new triangle which is P n prime m prime with 4 x plus 6 and P n prime. What are we required to find? We are required to find x. So for finding x, we need to consider now. Let's consider this triangle here, the newly formed triangle, which is this one I'm highlighting in red. Type of a triangle is that one. It's a right angled triangle, that's correct, which simply means that there are two things involved here. It's either you are going to use what? Your Pythagoras theorem or the SOHCAHTOA. Now, considering the fact that you have an angle and a side even completely, you can simply use what? The SOHCAHTOA. For Pythagoras theorem, you need to have at least two sides, and you can find the third side. Now let's find the value of, first of all, we are going to find Pm prime, which is this side here. I'm highlighting on green. That side. There, let's find it. So what do we have? Make sure you just start here. Angle 25 degrees. And then if you check that 4, it's actually an opposite side to the 25 degrees. And then your P, M, prime. This is actually the adjacent side. You have your OA, which means that's the tan theta. So your tan maybe let me write it this side here. The tan 25 degrees is equals to the opposite. It's 4 divided by P M prime. Now making P M prime the subject, you are going to do the cross multiplication here to get your P M prime tan 25 is equals to 4. Divide both sides by tan 25. You are going to get your Pm prime is equals to 4 over tan 25. Let's do this. Now we can easily put this guy on a calculator. Let's go to our calculator and put that. It's giving us this answer here, which is 8.57. So this is giving us P M prime is equals to 8.57, and then rounding off to 3 significant figures. Let's just count 1, 2, 3, which means we are going to end at 7. Let's check. This number is bigger than 5, which means that you are going to add 1. And then your 7 plus 8, it's going to give us P M prime is equals to 8.58. Now let's find x. X plus 6 is equals to Pm prime, which is 8.58. Subtracting 6 from both sides of the equation, x is equals to 8.58 minus 6. Now, you subtract 6, there you are getting that your x is equals to 2.58 units at meters. Check all the marks as they are. These things just 3 marks. Next question. Trigonometric function. Let's check it. So basically you are required to sketch the graph of 3 cosine 2x minus 1. This 3, it's actually the amplitude of the graph. And this 2 is giving you the period of the graph, which means inside 360, you are going to have 2 of these waves, 2 complete waves. And then this minus 1 is actually shifting the graph by 1 unit down. Let's plot it. So first things first, let's find this stepping here. So to find your stepping, you are going to first find the period. So for your period, it's nothing but take whatever is there in the brackets, which in our case is 2x equated to 360. Then solve for x, which means your x is going to be 2 divided by 2 both sides. Then your x is equals to 180 degrees. That's your period. Then divide the period by 4. You are getting your stepping, which is 45 degrees. Now let's just put that here. We have 45, 90, 135, 180, 225, 270, 315, then 360. And then your cosine of 0 is 1 times 3, it's giving us 3 minus 1, it's giving us 2, which means the first point is coming here. That's the first point. And then at 45 times 2, it's 90. Then cosine 90, it's 0. 0 times 3, it's 0. Minus 1, it's negative 1. So it's coming here. And then we are at 90 now. 90 times 2, it's 180. Cosine 180 is negative 1. Negative 1 minus times 3, it's giving us 3. Negative 3 rather, minus 1 is giving us negative 4. 1, 2, 3, 4. So it's going to be there. Next, 135. 135 times 2. It's giving us how much? Let me check. 135 times 2 is 270. 135 times 2 is 270. Then 270 cosine 270, it's 0. 0 times 3, it's 0. Minus 1, it's negative 1. Then this point is there. Now we at 180. Cosine 360, it's 1. 1 times 3 is 3. Minus 1, it's 2. And that's a complete wave. Which means the next one is going to be a repetition. From here, we are coming here. Then from here, we are coming there. And then this one, it's here. The last one, it's there. Now let's draw this wave. Throw this wave, something like this. Make sure it's a smooth curve. And that's the graph. Next question. State the range of values of x for which this graph is decreasing. So we want the point where the graph is going down. This is it. And this point here. So that's where the graph is decreasing. So it's from 0 to 90 and from 180 to 270. Let's just write that. This is when your x is actually from 0 to 90, or from 180 to 270. And that's the solution for this question. Please refer to a video. I'll place a link in the description. I'll just place a link for this question number 3. Already solved. This question, ABCD, is a trapezium with DC parallel to AB. Base DC is 6.4, DB 10.9, angle CDB 38, and angle DAB is 45. Find CB. Where is CB? It's on triangle DCB. This is CB. And then what are we given for this triangle? That's CB. There is no 90 degrees in that triangle. Maybe angle C it's 90, but you've not been told that it's 90. So you cannot use either Pythagoras or Sokatoa because there is no 90 degrees. So you are supposed to think of the sine rule or the cosine formula. Let's check what are we given. Just remember, when you have a complete pair and the other two sides, it's cosine rule. When you have a complete pair and an incomplete pair, it's the sine rule. So for this one, that's an incomplete pair together with the other two sides, which means for this question, you are going to use what? The cosine formula. Now, what is it? It's going to be your CB squared. This should be equals to, don't think this one will fit. Let's write it here. CB is equals to the other two sides, square each of them, 6.4 squared plus 10.9 squared minus 2 times the other two sides, 6.4. What just happened here? 6.4 times 10.9 times cosine of the angle. The angle is 38. Stop wasting your energy on this thing. Just take it as it is and put it in your calculator. Let's go to our calculator. Put that thing as it is there. It's giving me 49.826. So your CB squared will be equals to that. Put the square root on both sides. Your CB will be equals to the square root of that thing. Just put this thing as it is on your calculator. As it is. We are getting CB is equals to 7.058, which means your CP is equals to 7.06. What are the units here? It's centimeters. Then take your 2 marks. Next question, find the angle ADB. ADB. Well, for this one, we are going to use two methods, or rather two geometric properties. First of all, we can use the property on alternating angles. So your alternating angles are these ones. 1, 2, 3. So this angle is equals to that angle because they are alternating, which simply means that here you are going to have your 38. And then to get this angle there, we can put x to say x plus 45 plus 38 is equals to 180 degrees, sum of angles in a triangle. So this is x plus 38 plus 45 is giving me 83 degrees. I hope that's correct. Let me verify. Yes, correct. So this is 83 is equals to 180. Subtract 83 from both sides. X is equals to 180 minus 83, which simply means your x is equals to 97 degrees. Alternatively, you can use the property of co-interior angles. From this line down to this one and that one. This angle here plus this angle there should give me 180 because they are co-interior angles. So I'm having what? Yo, 45 plus x plus 38. This should give me 180 degrees because they are co-interior angles are supplementary, or they add up to 360. Then again you have your x plus 83 is equals to 180 degrees, which means your x is equals to 180 minus 83, which is going to give you a 97 degrees. So probably same one and the same thing. Now length AB. Let's find AB. AB is actually this one here. Let's check from triangle ADB. We have a complete pair here and incomplete pair here. Means we can find this. No. We already know what the value of x is. This is 97, which in turn makes this to be an incomplete pair. So we are going to use the sine rule. So it's going to be, let me write it here so that I can be easily referring. AB over sine 97 is equals to 10.9 over sine 45. Multiply both sides by sine 97. You are going to get that your AB is equals to, let me do this, 10.9 sine 97 divided by sine 45. Now let's put that in a calculator. Let's put it on a calculator. Then this thing is going to give you 15 point AB is equals to 15.30000, which means AB, three significant figures, don't forget it's 15.3 centimeters. Then for the area of BCD, it's this triangle up there, two sides and an included angle, 10.9, 6.4, and then there is an angle between those two sides. So the area is half AB sine C. So this one is equals to half AB sine C. And then the area is going to be equals to half A 6.4 B 10.9 sine C. What's the angle between the two sides? It's 38. Just put this thing on your calculator. And that's the answer. Which is approximately 21.5 cm squared. Question number 5, whereby you are required to state the amplitude and period of a trigonometric function. Maybe let's start with some kind of a recap. To say, given a trigonometric function f of x is equals to a sine bx plus c. What do each of these letters A, B, C give you? A is telling you the amplitude of your function. Your B is telling you how many waves are you going to, how many complete waves are you going to get in the period 0 to 360. So in other words, your B is giving you the period, and then C is the vertical shifter. And then in our case, we are ignoring we don't go into deep details in considering the vertical, sorry, the horizontal shifter, which might be a number that is here, whereby you can say it's a plus D, plus it's going to shift this graph to the left by d units, and then if you say minus d, this is going to shift the graph to the right by d units, but we are not considering that part in this case. So the first question, you are given y, or f of x is equals to cosine x. What is the period? What is the amplitude? And amplitude is going to be a number placed before the ratio. Here in our case, there is no number, which means there is 1 there. So let's just write it. The amplitude is 1. Then for the period you are going to take whatever is inside there and equate it to 360. In our case, you have your x. This should be equals to 360. And then since it's already simplified, which means the period is just equals to x period is equals to 360. Next, still we want to find the amplitude. Amplitude is nothing but the number placed before the ratio. So this one here, the amplitude is 3. And then the period, we say take whatever is in this bracket and equate it to 360. In our case, we are having what? Half x, which means you are going to have a halfway from 0 to 360. So to find the period, just take all of these and equate it to 360 degrees. So you have x is equals to 360. Then solve for x. Can multiply both sides of the equation by 2. Then your x will be 360 times 2, which is equals to 720. Which means your period is equals to 720 degrees. Next question. You are required to solve what? Trigonometric equations. Let's just take a small recap on this one too. So, given a trigonometric equation, to solve this type of an equation, all you do, first isolate the ratio. In our, for example, sine x is equals to 0.3. The ratio is isolated. From there, find the reference angle, which is going to be the arc sine. Of 0.3. And then this is going to give you what we call a reference angle. What is it giving us? Let's calculate. So this is nothing but arc sine, so it's shift sine 0.3. Then let's check the answer. Equal 17.457, which is 17.5. This is 17.5. Now, how do you find the angles from 0 to 360? You need to remember this. The cast diagram cast, C-A-S-T. That's cast. Or there are different ways to always remember this. You can start from the first quadrant where there is A and say all students take coffee. Or you can just start from the fourth quadrant and say this is the cast. And some even go crazy to say it's all science teachers are crazy. So you are going to choose whatever works for you. So what does this cast diagram tell you? Where there is A, it means all three trigonometric ratios are positive. Where there is S, only the trigonometric ratio which starts with S, which is the sine, is positive, which means both tan and cos on the second quadrant are negative. Same applies here, only tan is positive, and here only cos is positive. Tan and sine are negative in this quadrant. And then, so what you are going to do is to check the given equation. In our case, we have sine, and this sine is positive because there is no sine here. Either positive or so it's positive. It's sine that is positive, and sine that is positive is in all and here. So to take the reference angle to the first quadrant, you just write it as is. So this one is going to give you x is in the first quadrant 17.5, or x is in the second quadrant, it's 180 degrees minus the reference angle, which means let's calculate. (180) minus 17.5. (162.5). So those are your two angles. So basically that's how you find the solutions. Let me write here, to take an angle into this quadrant, it's 180 minus the reference angle to this quadrant, it's 180 plus the reference angle, and then to the fourth quadrant, it's 360 minus the reference angle. So for this one here, already everything has been simplified for us. So we are just going to say our theta, that means x for theta, is equals to arctan square root 3. And then we are going to get the answer here for our reference angle. So let's go and calculate arctan square root 3. It's 60. So let's come here and put 60 This is 60. So let's check the signs. What do we have? It's a tangent and there is no sign here, which means it's positive. Which quadrant is tan positive? It's this quadrant and this quadrant. So our x is going to be the first quadrant. You just write it as is, or x is equals to third quadrant 180 plus 60, that's 240 degrees. And those are your solutions. Get your 2 marks. Next question. For this question, it's kind of tricky. Why do I say this one is kind of tricky? You first need to isolate the ratio, the trigonometric ratio, sine x. This one must be the subject. So how do we get that to be the subject? First things first, subtract 1 on both sides of the equation. So you are going to have something like -1 here. And then -1 also this side. Then this thing -1, this is gone. And then 0 minus 1 is going to give you a -1. So you are going to get your 2 sine x is equals to -1. Then where do we go to from here? You are going to divide both sides of the equation. Divide both sides by 2. So that these 2 cancels these 2. And then you are left with sine x is equals to -1/2. Then let's find the reference angle. Now, please make sure you don't include the sign when calculating the reference angle. So this is arcsine 1/2, not arcsine -1, or don't include the negative there, because the negative there, what it does, it just tells you which quadrants are you going to. So arcsine 1/2, that's 30. Let's confirm using the calculator. Let's confirm. That's 30. Now, which quadrant? We have what? We have a sine. And this sign is negative. Let's go and check. So, which quadrant is sine negative? Sine is positive in this quadrant and this quadrant. So the other two, it's where it's negative. So it's this and this. So we are going to add 180 to the reference angle and also subtract the reference angle from 360. So let's come back here. Our first x is going to be in the third quadrant. And then we know in the third quadrant, it's 180 plus the reference angle. And then this means that x is 180 plus 30. This is giving me 210. And then the other one, it's the fourth quadrant. So in the fourth quadrant, it's going to be 360 minus the reference angle. So the x is equals to 360 minus 30. So your x will be equals to 330 degrees. Now let's go and put in the solutions there. 210 and 330. Question number 7. ABCDE is a pentagon, which simply means it's a polygon with 5 sides. Now, let's check the question. Let's check the diagram. For this diagram, you have an angle down there 64 degrees, side 41.1, 38.6, 56.5, 78.4, and an angle of 94 degrees at B. And then you are told the diagram is not drawn to scale. What is the meaning of that? Why do questions always put these statements here? This is to tell you that you cannot use a protractor or a ruler or any measuring instrument to measure stuff because it's not drawn to scale. Nice one. You are required to calculate AD and show that it rounds to this 194.5 meters, which is correct to 1 decimal place. Now let's check AD is in 2 triangles. There is this triangle up here, this one, and there is this other triangle down there. From the first triangle, which is this one here, we can see we've got 2 sides, and this side AD. So if you are given 2 sides and you want to find the third side, you must use what? The Pythagorean theorem. But in this case, nobody told us the size of this angle. So not unless we know it. If it's 90 degrees, you can easily use the Pythagorean theorem, but we don't know that. So let's check this triangle down here. You have a side, you have an angle, and then you need to find another side. For that, you are going to use what? The SOHCAHTOA. Let's use SOHCAHTOA to find that. Here you go. SOHCAHTOA. Let's check. We have an angle 64 degrees. We also have a side that is adjacent to the angle, and that's 46.1. Then the required side is actually an opposite side to the 64 degrees, so that's 80. And then you have an OA. Definitely OA is what? It's your tan. Since you have A and O, it simply means you must use this ratio there, tan. So using tan, you are going to say, put it down here, tan 64 is equals to the opposite, it's 80, over the adjacent, 46.1. And then from there, multiplying by 46.1 on both sides, you are going to get that your 80 is equals to 46.1 tan 64. Now let's take this thing to our calculator. Maybe let's put it here first. Calculator, let's bring in our calculator here. Here is our calculator. We need 46.1 times tan 64. And that's the answer, the 94.51. 94.51 900709681. Now we need to round off this one to one decimal place. So rounding it off to one decimal place, we are underlining the 5 here. And then after underlining 5, you add 0 because 1 is less than 5, so plus 0 here. So this thing is giving us what? The required answer, which is 94.5 meters. Next question, calculate angle BAC. Angle BAC, where are you? BAC, it's this angle here. How do we find that angle there? Let's check what do we have. Don't forget, two sides included and two sides with, if you are given two complete pairs and a complete pair and an incomplete pair, use the sine rule. If you are given an incomplete pair with the other two sides, you use what? The cosine formula. Let's check for our case. From this angle to that, the side is known. The side is known, but the angle is unknown. So we call that an incomplete pair. This one to that, they are both known. So we call that a complete pair. So we are going to use what? The sine rule for that. Starting with the unknown. The unknown is the angle A there. So you have your sine A over 56.5. This is equals to sine 94 over 78.4. Now let's take this thing to a proper working space so that we can see everything clearly. Now this is our proper working space. Nice one. Now let's solve for sine A, multiplying by the denominator on both sides, 56.5. You are going to get that your sine A. Let me work on this one already. Sine A, this is equals to 56.5 sine 94 divided by 78.4. So this one, your sine A, is going to be equals to, let's bring in our calculator for this. Now here is our calculator. Let's put in everything there. You have your 56.5 sine 94 over 78.4, and this is giving us 0.719. This is giving us 0.719. And then let's do find A is equals to A will be equals to arc sine. Zero 0.719, and this is going to give us, on your calculator, put this number as it is. Avoid rounding off, avoid premature rounding. So here you just press on your calculator second function or shift sign, and then your answer. This is giving us 45.964. 45.964 something. Now rounding off this thing to one decimal place, your A will be equals to 45 point, it's actually 46.0. Because you underline the 9, add 1 to 9, it's 10, then you write 0 and carry 1 on 5. So 1 plus 5 is 6. 46.0 degrees. Now let's go and write that. Let's write the solution for this angle. It's just 46.0. Next question. Largest angle in triangle CAD. Largest angle in triangle CAD. Triangle CAD is actually the triangle in the middle there. This triangle here. So what is the largest angle here? It's obviously this angle there. Now let's check. What do we know? We've already calculated this side to be 94.5. And then let's check. So for this is unknown. The angle is not known, but the side is known. This is not known. So that's called an incomplete pair with the other two sides. So we are going to use the cosine formula for this. Now let me just write it down so that I can take it to a proper working space. 94.5 square. So it's going to be the side opposite to the angle squared is equals to the square of the other two sides. So it's 38.6 squared plus the other one 78.4 squared minus 2 times the product of the other two sides, which is times 38.6 times 78.4 cos, sorry for what just happened there, cos C. Now let's take this to library office. Now we are in library office. This is what we have. Let's put types here. And also here. So what we are going to do here, it's the following. Maybe let me take this to the next page. So what we are going to do here, we are going to take these two to the other side, to this side here. We are just taking them to that side. And then you are going to get something that looks like this. (94.5) squared minus 38.6 squared minus 78.4 squared. This is equals to -2 times 38.6. Maybe let's put this one on a calculator. Maybe let's put that on a calculator. There, 2 times 88.6 times 78.4, and that's giving us 52.48 cos C. Now let's check what's on the left. What does it give us? The 94.5 squared minus 38.6 squared minus 78.4 squared. This one is giving us 1293.73 is equals to -60. 52.48 cos C. Then solving for C cos C, you divide both sides by the -60.52. Then you will get cos C is actually equals to 1293.73 over minus 60, 52.48. Now let's put that on a calculator so that we know what C is. So it's 1293.73 divided by negative 60, 52.48. So this is negative 0.213. And this number is continuing. So this will be equals to, just come to your calculator and do the second function of cos or shift cos. Answer. This will give you a 102.3423230489. Then round this to 1 decimal place. Then your C will be equals to 102.3 degrees. Now let's go and write this solution. Let's go and write this solution. (102.3). Next question. Now this is a question on application of area. And then maybe just a small recap on the concept of area. There are two ways in which we calculate the area of a triangle. So the area will be equals to half base times the perpendicular height. And then the other one for calculating area, it's when there is no perpendicular height. And then you are given two sides together with an included angle, or rather two sides with the angle between those two sides, which we call an included angle. So in that case, what you just do is just to say it's half AB sine C. Now, this formula is actually reduced to this formula here. For example, let me take you through an example. Consider this triangle here. Consider that triangle there. So what happens here is, let's just say I decide to draw the perpendicular height, so that this is my height h and this is my base. Now, if I know this angle here together with this side here, let's just say what I know for this triangle, it's this one. 1, 2, and 3. And I want to calculate what? The area. From that, I know area is equals to half base times perpendicular height. Half. What's the base? The base, it's the 34.3. And then times the height, which are, just label it h there. But then the h is what I don't really know. Now, from this triangle, this right angle triangle that I've just highlighted with an orange color. Suppose I know this angle and that, and I want to find h using SOHCAHTOA. What will be h? H is an opposite, and then x is the hypotenuse, and then I have the angle there, which is P. And then O and H, that's sine. So technically, I'm having sine P is equals to, the opposite is just H over the hypotenuse, which is X. So from there, multiply by x both sides, then I know h will be a. It's going to be x sine p. Now if I replace here with x sine p, I'm going to have of the base, which is 34.3, times the height, which is x sine p, which is actually this formula here. That is where that formula is actually coming from. Let's have AB sine C. Now, we are required to calculate the shortest distance from R to the line PQ. And the shortest distance is actually a perpendicular line drawn from R to PQ. Something like that. That's the perpendicular line. And there is your 90 degrees there. And then we can call that distance h. Now let's calculate h. From this triangle here, since we are given two sides and an included angle, we are going to use this trigonometric area formula. And then for this triangle, since we have a base and a perpendicular height, we are going to use this formula. So first things first, let's find the area of M and L. Area of triangle M and L will be equals to half AB sine C. So this is giving us what? Half A 21.5, 27.6 sine. What's the angle there? 3.1. Then what will this thing give us? This thing is going to give us, let's bring in our calculator here. Maybe let me place it that side. Nice one. So it's actually a half of 21.5 times 27.6 sine 111, and it's giving us 276.99331254172, which is an irrational number. That's not our interest. And then we are told from the statement there that the triangle PQR has the same area as the triangle element. So the area of the other triangle, there, PRQ is equals to the two 176.993 centimeters squared. But then since we have a base and a perpendicular height, we are going to use this formula here with a base and a perpendicular height. So the area of triangle PQR will be equals to half base times the perpendicular height. So this is equals to half. What's the base? The base is 34.3, and then the height is h. Then this area it's actually known, it's this number here. Then from there, let's solve for h. First of all, let's divide 34.3 by 2. Let's bring in our calculator here. This is the Casio calculator. So this is 1/2 times 34.3 is giving me 17.15. Then divide both sides by 17.15. You are going to get that this is over 17.15. Then your h will be equals to now. So our answer, which is to divide by 17.15, giving me 16.151 21355,928. Round off this to one decimal place. H is equals to 16.2 meters. Sorry, centimeters actually. Next question. It's on the trigonometric 3D. Well, concerning the trigonometric 3Ds, all you do just try to locate a right angle triangle and use either your SOHCAHTOA or the Pythagoras theorem. If the triangle formed it's not right angled, you will use the cosine formula or the sine rule. As simple as that. Now let's check. The diagram shows an open rectangular box, and then AB is that, BC is that, and CG is that. As thick AGM rest against A and G and extends outside the box to M. Then you are required to do what? To calculate the angle between the stick and the base. So the angle between the stick and the base is going to be an angle between this. In this triangle, I'm highlighting in orange. And that triangle, in that triangle, what we know, it's only this side. We need to first find this side. Then you will be able to use your tan theta to find the required angle there. Now let's find that. So to find side AC, you are going to use the Pythagoras theorem because you are given two sides and you want a third side in a right angled triangle. So your AC squared is equals to 18.6 squared plus 9 squared. Then your AC squared, this is equals to, let's bring in our calculator here. (18.6) squared. This is giving me 3. (345.96) plus 9 squared. It's that. And then if you add 9 squared on that, we are getting that AC squared is equals to 426.96. Taking the square root on both sides, AC will be equals to the square root of 426.96. It's giving us 20.663010 42927. Round this one to 1 decimal place, then your AC will be 20.7 centimeters. Remember, we are not interested in AC, but rather we are interested in finding the angle there. So it's going to be, now we know this guy here is the 20.7, and then we also know that, let's find the angle here. So this angle, this is adjacent and this is opposite, so we use tan theorem. So this is going to be tan of the angle, let me call it x, is equals to the opposite 14.5 over 20.7. But remember to use the answer from your calculator in calculating. So x will be equals to arc tan 14.5 over 20.7. So this, we have 14, sorry, it's arc tan, so that's shift tan 14.5 over the answer. Then just click equal. This is giving us x is equals to 35.058761, which means that x will be 35.1 degrees. Now let's check something here. How if somebody decides to round that one off and use the 20.7? Yeah, it's close. It's 35.0 when you round it off. Now it's defined, exposes you that you actually did what? Premature round, which is rounding off while you're still working. Now this question requires us to do what? To find, let's hide this guy just a moment. Show that GM is 4.8 if AM is 30. we need to find AG, side AG. So to find side AG, straight talk, we are using Pythagoras theorem because you have your ACG, which is a right angle triangle. So from there, you are going to have your 20.7. Remember, the answer for 20, it's this one here. You will use it as is squared plus the 14.5 squared. This should be equals to AG. Now let's take this down here. AG squared. Then our AG squared is going to be equals to, let's bring in our calculator here. Let's bring in our calculator. So it's 20.7. Let's use this one as is. So this is the 20.7 squared plus 14.5 squared. And this is giving us 637.21. Then taking the square root on both sides, you are going to get that AG square root 673.21 is 25.9. This was 6,630,101,42. 637, not 673. It's 637 here. 0.21, then the square root. $25.2. Now, if the AM is equals to 30, this means that MG will be 30 minus 25.2, which is equals to the 4.8 as required. Thank you for staying tuned. Hope that was an educational lesson. Stay tuned for other videos.